So the question came up the other day of how to put threads into your rapid prototype parts. Um, and so that kind of led into a discussion of what is the difference between the thread tool here that we can use and also the coil tool. Um, so my basic feeling is that if you know a specific piece of hardware that you're going to mount up to, in this case a screw or bolt, then the thread tool is the way you want to go because it's set up to basically give you that information. Whereas the coil tool is going to give you a limited amount of cross sections, but as long as you match them between the two parts, you're going to be good, and you'll be able to use it as a thread then. So let me kind of go through and show this. So let me see if I can go back and resuppress some features. Now let me turn on the analysis. So what we're going to look at is up here is a thread that it was put in along with this counterbore hole that we'll talk about. And then a bolt was gotten from McMaster Car. So this is all kind of standard hardware. So if I was making this part and wanting to put this bolt into this, I would then do a thread in here to get it to match. Down here, where I have these legs that kind of are base pieces that I'm going to assume get screwed on, I did those with coil. Okay, so let me kind of go through real quickly and show you the difference. So I'm going to go in and suppress that feature, which will end up suppressing the bolt as well, simply, or well, actually it's there in the middle because it was made it up to the hole here. Let me also go in and suppress the hole just so we can kind of go through and look at that as well. Okay, so underneath create menu there's the option to do a hole. You basically give it a face, and then on that face you get to move this around and kind of position it so it will normally snap to the center there. And then with this you can go through and set up what kind of hole that you want to do. I'm going to choose a counterbore. Okay, so it gives me this depth counterbore there, and I'm going to set it up to not be all, which is going through it all, but to simply go a depth, which the depth will be 1 inch. Okay, hole diameter is 1/4 inch. Angle in this case is 118. That's the end piece, or little angle right there. Counterbore depth of 0.2 inches, and then finally the counterbore diameter, which is a little bit bigger in the hole. So if I was going to use a socket or something like that, you could go with that. Okay, so that's the options. Now we could go with a simple one, which is just straight down like that. You can go with a countersink one, which is this is at an angle versus being a counterbore. Okay, so we'll go back to that, just double check everything. Alright, good. Now, as far as hardware, okay, so I've gone in and go to the insert McMaster Car. So this is going to be basically, going through doing a screw, looking for a particular type of bolt and so forth. I got the part number here, so I'll just paste this in real quickly. This was when I'm just using this McMaster Car right now, it's just to get a representation of the bolt to come up. So that's that information. So this is kind of like a 1/4 bolt that is, I think, a 3/4 inches long. Okay, right down there, 1/4. So when you get to this, I hit product detail. Down below is where I can say insert a step file. Here's the particular about the sizes and all. So if I'm going back, I can go back and make sure my counterbore fits that, overall length of it and so forth. Let me hit save. This will drop in the bolt right there in the middle. I'm just going to leave it as is right now. Okay. Now what I'm going to do is do a joint, because this is a separate component. So I can now join it to the print the original one off to this hole. So if I hit J, gotta select my component. Now unfortunately this is one of the challenges of doing this particular piece of hardware. There's not a real good way to select, at least to get to a kind of a common. It'd be great if I could find a basically a circle with a hole in it. The one that I came close to is this one on the end. Okay. Now over here, got kind of the same issue, but I can use that kind of counter sync right there and click on it. Now it came in the wrong direction, so you flip it. Okay, came in and got it oriented right. Now let me move this up a little bit. Okay, and I know it's going to be a little bit about like that when I end up with doing everything, so go with that for right now. Alright, so we got a bolt in place. Now, let's go look at the thread, and actually let me turn that off for a second just to show you this. So when we do a thread, you basically select the hole, and based off the hole, it will give you standard kind of setups. This ends up going with the exact same information. I need a quarter 20 UNC as far as the design, so that matches. That's really good. And then I got a choice of doing either this, which is just a representation, although if you do a drawing, this information is there. As you can see, there's really no actual threads cut into this. It's just a quick representation of it. Let me go back and edit this and choose this option to model the threads, and now we see everything that's in there. Okay, I hit OK to this. Let's go back and turn that piece of hardware back on, and it's a little bit off. It ends up the cuts for this are a little bit wider, which if you're wrapper prototyping something like this is probably good. That way it has a little bit of a play within it. So it's not located pretty good on that part. So that's where you really would use a thread. That you were looking for existing piece of hardware, quarter 20, quarter 28s, all that stuff is pretty standard that you would find like at Home Depot. You can find a wide variety, purchase that, and then you go in and set up the hole, and then you choose the thread tool, and it will probably give you the choices there that are closely matched to that. Alright, now, case of a coil. Alright, I'm not going to go through all this, but let me just show you this kind of basic one. So, the biggest thing about doing the coil is you got to basically do one on one part and do the opposite on the other, and then you can't have the two parts visible at one time, otherwise it'll join it together when you do the second one. So let me turn off the main body here. So there is the thread that's cut into this one. Okay, and I think that's the one that's doing it. So let me edit this real quickly to show you. So with this, you choose the diameter. So I'm going to click on there and go over and specify direction. The number of revolutions you want to do, although you can do it several different ways there as far as the actual type of coil. Overall height, so this one I made 0.4 to go with that total height there. Cross sections, you basically only get 4, or 3 I should say, and the triangles kind of goes 2 different ways. So not a lot of choice, but once again, to do a simple kind of thread like this, probably the triangle to me would work the best. Then you get to choose this to be on the inside outside. So if we look at where the coil will be creating, this is currently on the outside. Inside does like that. So in choosing the outside, it pushes it out. Okay, so like right there. So that kind of does the maximum depth as that part, and then you got to make sure the section size. When this first is created, it's going to be really kind of large and way out of whack, so you just got to kind of cut it down. All right, so I'm going to edit that. Now let me go back and turn the other one back on, and basically you do the opposite in the other one. This one, when I edit this, will be outside, but it'll be the other type of triangle to go outside like that, so that works. Same information as far as the rest. Okay, and this one actually joins, it doesn't cut. And so that's a quick and dirty way to get a thread that is just simple coil that would be for your own setup, so you don't have to worry about this, very fine detail that you see in something like this. That this is probably going to be work more effectively than doing actual threads and all with it. Okay, so that's a quick lesson about when would you choose between doing a thread or doing a coil. And most of the time, if you're putting it in on both of the parts, you're going to do a coil then, whereas otherwise, if you've got existing hardware to match, then a thread's going to be your option.